So for this one, construction industry actually using a ladder to solve the problem of regulation spin, right? So the ladder is to reach a height of 5.6 meters. So what that means is if you have a wall, okay, and you've got the floor, is that where the right angle comes from? Okay? So then you have a ladder propped up against the wall. Okay? My diagram is not drawn with a ruler, which is why it's not very good. It says if the height is 5.6 meters and the distance of the base must be at least 1.4. Any ideas why that would be a requirement? You used ladders before?
Because if it's straight up, it's going to fall back.
Yeah, if it's too close to the wall at the bottom, it will just fall. Yeah. So this is where that has to be a certain length, and then that determines. Remember, we said that if the ladder is a certain length, then the further you move it away, the less it will go. Yeah? So it says how long should the ladder be? So there's our x. So we know right angle triangle that 5.6 squared plus 1.4 squared equals x squared. So have you done that, guys? What did you tell me the numbers?
31.36.
31.36
Plus 1.96.
1.96 equals x squared. So we add that together, we get
33.32.
and we take the square root of that to give us x, and you end up with, so it's 5.7 what? 77. So if we round it correctly, then we should have 5.8 meters. Make sense? Understand? Make sense? Sure? Understand? Good? Okay. So then B, a ladder measuring for, are you all good with this, guys? No, you don't get this one.
It's because of the two different measurements.
Okay, so a ladder measuring 4 metres needs to have its base 90 centimetres from the wall. How high the wall can the ladder reach? Now that's the type of question we did when we had the picture. So this time, what are you expecting, by the way, in a Pythagoras' theorem question when there's part A and part B? This is like exam technique. What are you expecting to have to do? Nothing? You're not expecting anything? Because it's nice to think I actually know what's going to come, so I'm ready for it. What are the two options with Pythagoras' theorem? Addition and subtraction. We have just done addition. What are you expecting? Subtraction, yeah? In an assessment, they're very rarely likely to get you to do the same thing twice. Once they've asked you it once, they're not going to ask you to do the same thing again. Not in an assessment. In a lesson where they're repeating things, maybe. But in an assessment, so if we look at this, we're saying the ladder is 4 meters. Okay? It needs to have its base 97. Now, how do we write that? I'm just putting the measurement in. How do I write? Do I put 97? I have to put it in it's in centimetres, right? But this is in, so what do I have to write it as? Not 97, but 0.97. Yeah? Have to be careful. This is where the other thing is. So this is in centimetres, this is in metres. So you have to be aware. Alright, did you get that? No. So then this is the x. Alright? This is the x value that I want to know. So we kind of expecting to do subtraction. So we do x squared plus 0.97 squared equals 4 squared. Now can you see why it would make a big difference that I have to have 0 point. Imagine if I had 97. Why is that now wrong? Sam? And also,
because that this number, the number can't be bigger than the hypotenuse.
exactly, this is the longest side, isn't it? That number has to be bigger than that. So let's say because we've got it in centimetres and this one in metres, it gives me the situation where it now looks like the longest side, that is the longest side, we've already decided, but that number's bigger. So that should make you think, that needs to be 0.97, right? So that it's all in metres. What would be the other option? Do x squared plus 97 equals, not 4 squared, 97 squared equals, nope, nope, 400 squared, isn't it? Because this one is all in metres, but these two would be in centimetres. So you can do that, either or, but if I do the first one, my answer is going to give me it in metres. If I do the second way, it's going to give me in centimetres. So as long as you're aware of that. Which one do you want to do? The top one. Okay. So I'm going to rub this out. It's in the video, so you can watch it afterwards. All right, so we do this one. What do we do next then? So we've got x squared plus feel free to do it, unless your fingers have been chopped off. 9409 equals 16. Now what do I do? Subtract. So x squared equals 16 subtract 0.9409. What do you get? 15.059. Exactly that. And then what do we do to finish off with?
Square root. Yeah.
So then we have to do the square root of 15.0591, and we get 3.88. 3.88 what? Meters. Good. So I can just check if I put that into the triple 3.88 meters. What was it after the 8? We're fine then. 3 figures like that is normally pretty good, especially because it's meters and centimeters, yeah? So we do 388 centimeters, is perfectly reasonable. Does that make sense? Because it's not far off the length of the ladder, because the ladder is really quite close, isn't it? So, just a bit. Right. So there is a tip, by the way. We've got 2 Pythagoras' theorem questions. A, we're going to add. B, we've had to subtract. Yeah. So this one was the a squared plus b squared equals c squared, and this one we were c squared subtract a squared is b squared. Okay? Just so that's something to keep in mind. If you have more than one question in like an assessment with Pythagoras' theorem, or A and B in a Pythagoras theorem question, expect one of them to be subtraction. It might not, but it's probably going to happen. Okay? Does that make sense, those questions, guys? Next one then. Okay? You've done it. Those that haven't, go for it. You can't. Now, this one, guys, can I just ask you? It says the heights of 2 vertical towers are 75 and 65. If the shortest distance between the tops is 61, how far apart are the middle of the bases of the towers? So, for me, I can sort of tell you that if I give you a line, okay, might make my picture a bit bigger. What that means is, if I draw from here straight down the middle, okay, and then here straight down the middle, okay. So we want to know the distance between those two lines. How do you? Is there a right angle triangle there?
Yes.
Where?
Right
Top of here. Where'd you go?
To the left.
To the left, exactly. You go across. Yeah, and then you go up,
So 3.69.
and then you go down. They're just my on the computer for me there, I think. But we could then take that it says the heights of the two towers are 75 and 65. So what does that mean? This height is 65. This whole height is.
70.
So how high is the side of the triangle? So right from the top to the bottom is 75. From this point here to the bottom is, so what's the red bit? 10, good. That's the 10 meters. That's the extra step you need to do. Alright? It said if the shortest distance between the tops of the tower, so where do I put 61? If the shortest distance between the tops of the towers.
So
Top,
Oh, the
Top.
height.
the hypotenuse, isn't it? Hypotenuse is 61. How far apart are the middle of the bases of the towers? So that, by the way, the middle of the bases are, here's the base, here's the base. Do I need to find that distance, or will this one do? That one will do. Yeah. Because this distance up here is exactly the same as that one down there, isn't it? Yeah? So I can just solve this. Now, is it an addition or a subtraction? Do I need to worry about units, or are they all the same? They're the same, aren't they? They're in what? Meters. Meters, meters, meters. Okay? Go for that. Okay, so we've got 100 plus x squared is equal to, what do you get, 61 squared is? Then we've got x squared is 3. Right, 100. So that is 61. Then x is the square root of 361. What did you get? 60.17. So if I said to three significant figures, that would then be 60.2. Yeah. So that's 60 point. And does that make sense?
Yeah.
Okay. Now, what can you say, just out of interest, about that diagram? Does that diagram, given the number that we've just calculated, does that diagram look realistic? Why not? Yeah, this looks 60 and 10. Now, in reality, if I were to look at those towers next to each other from the distance, there wouldn't be much difference, top with that. Why do you think they've exaggerated it for us? Easier, yeah. Okay. Easier to view Because otherwise, what would it have looked like? It would have been, here's one tower, here's another tower, right? Work out the distance, and you'd have been like, oh, okay, so we've got that distance there and that one there. That's 10 meters, this is 60, you know. It would have been a tiny little, so they just exaggerated the difference. So, but it's always worthwhile looking at your numbers and going, does it make sense? So 61 and 60.2, that's fine, isn't it? As long as the 60.2 wasn't longer, but that 10 definitely isn't anywhere near the 61. So they've just exaggerated it. Okay. So, have you all done this one as well? Have you ever seen these guys out on the roads and stuff? They stand there with their laser and they point it at something. You ever wondered what they're doing? And they're literally pointing a laser to the top of something, and they're working out whether the road is kind of dipped or something like that, yeah? Because then they can point a laser. This machine will know if the laser is perfectly horizontal, okay? And then they'll point it to the top or bottom of something and decide how far it's got. Do you ever watch a program that sort of tried to prove that the Earth had a curve to it? No? So there was a situation where, it's quite interesting, I thought. We could think of it with Pythagoras' theorem now. So what they did was they had a shoreline and they had a lake, a big lake. So this lake. Now what do you know about water? There's no wind and there's no movement. It's perfectly, it doesn't go downhill or anything, does it? It's not like jelly that can be set a bit lower, right? So what they did was they had a man here, okay, and they had a man with a little machine, and what they did was they pointed a laser beam out across the water. Yeah? What do you know about laser beams? They go perfectly straight, there's no drop out, you know, as much as we can say. So the laser beam should stay exactly the same height above the water as over. Okay? And what they did was they actually had a helicopter, right, that flew out. But I think what the idea was, they were going to measure this laser, okay, and they put like a mirror in front of the laser. So when it bounced back and they could measure it. And they moved the mirror and they moved it. And what should happen? As long as the mirror stays at the same height, it should always just reflect back at you. Yeah? We had the helicopter. Now what actually happened? Yeah, so this lake actually did this. Exaggerating it. So what happened? The helicopter flew in a straight line around the lake with their mirror. But at some point, the laser stopped seeing the mirror. Why was that? Yeah, because the Earth curved away. Alright? Why did they do it on water, above water? Why didn't that? It was in a let's prove the Earth is not flat. Because water sits, no one can, the land was just curving away anyway. It's water, yeah? So that's right. Now, could you work out using Pythagoras' theorem? Anything, yeah? Yeah, we could say, right, well, let's try and figure out how far the lens went up, yeah? We're not going to do it, but you get the idea, yeah? We could pinpoint these points, like where was the helicopter sent, that kind of thing. Right? Make sense? Okay. But we actually get into things called something else with triangles. When we have this thing called the angle theta, right, will extend into what's called trigonometry. So Pythagoras' theorem has got nothing to do with angles, apart from which important angle? The right angle. It must be a right angle. Okay. Trigonometry is when we have different angles. We consider this angle as well. All right. So what have we got? 5 more minutes. You have. So let's just say you've got an assessment coming up, right? So you've got these kind of questions. You've got some more questions to finish off. All right. These are all criterion A type questions, even though they're in other situations. It's still just skills and knowledge. All right. We're going to be moving on to this map stuff as well. But what you can do if you wanted to prepare is in our. So you can see where the angle, this is the trigonometry, this is where we're heading to. At the end, in the unit review, there's going to be some triangles and things. Oh, it's all trigonometry. Right. Just things like this, find the side of the unknown side. The basic Pythagoras theorem. Yeah? Now once we've done that, we can move on. Don't worry about the ones with signs, and that's where we're going to next. Yeah, that's our next thing. You'll be absolutely fine. Lots of calculations. Alright? So, your assessment is purely Pythagoras' theorem, using triangles, but there might be things like the ladder is leaning against the wall and the distance between two things. There's also another situation, kind of like this, where if I said to you, alright, here is a cliff, and there's someone stood up on the cliff, and then here is the sea, and here is a boat, yeah? I could say, if they look at the boat, and they're this high off the ground, yeah? What shape have I created? Right angle triangle, yeah? So we could do that. If I know that they're, 200 metres offshore, and I know that this is 50 metres tall, I could ask you how far away the person is from that kind of stuff. But remember, it's all Pythagoras' theorem. And what are you expecting now, if there's more than one Pythagoras' theorem question? Yeah, think I'm probably going to have to do this one, or when I know the longest stuff. Okay? Let's